Welcome viewers, in this video we will see the algebra of function, the topic available in sets, relation and function. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. First you will see the addition. If function such that d1 relates r and function g such that d2 relates r, then their sum f plus g such that d1 intersect d2 relates r. So such that f plus g of x equal to f of x plus g of x. For all the x implies d1 intersection d2. So the name is addition. So the function f is available, relates r, d1 relates r. Function g is available, d2 relates r. While adding two function f plus g, we have d1 intersection d2 relates r, right? So the f d1 relates r, g d2 relates r. While adding d1 intersection d2 relates r. So that f plus g of x, we can add f plus g of x can be written as f of x plus g of x. So for all x implies d1 intersection d2, right? So the two functions available f plus g, while adding it will give f of x plus g of x. So that is the meaning. Similarly, subtraction. If function f such that d1 relates r and function g such that d2 relates r, then their difference f minus g, that is such that d1 intersects d2 relates r. So that such that we can write f minus g of x equal to f of x minus g of x for all x implies d1 intersection d2. So it is very similar to subtraction, very similar to addition. Addition we are adding. While adding two function, we can write it separately, f of x plus g of x. Similarly, while subtracting, we can write f of x minus g of x for all the x implies d1 intersection d2. Now we'll go to the product. Same thing. If function f such that d1 relates r and function g such that d2 relates r, then their product f into g such that d1 intersects d2 related to r. In that case, such that f dot g of x can be written as f of x into g of x. For all x implies d1 intersection d2, right? So this is about product. f1 we have f2, while multiplying these two we can write f of x into g of x. Similarly, we have the quotient. If function f such that d1 relates to r and function g such that d2 relates r, then their quotient f divided by q such that d1 intersects d2 is can be written as set of x such that g of x equal to 0 relates r, such that f divided by g of x equal to f of x divided by g of x, such that for all x implies d1 intersects d2, that is x, the set of x such that g of x equal to 0. So this is the quotient. Same thing, d1 function d1 relates r, g function g d2 relates r. So that f by q, d intersects d2, that is written as set of x, g of x equal to 0. We are taking g of x equal to 0, such that f divided by g of x equal to f of x divided by g of x, such that x implies d1 intersects d2, that is set of x, g of x equal to 0. That is related to the quotient. Then we'll have one more, then composition of function. One more term is available. If function f such that a implies b and function g such that b relates c, a relates b, b relates c, then the function f a relates to c defined by f of x equal to g of f of x for all x implies a. Right? This is a composition of function. The function a is function f is a related to b. Function g is b related to c. Function g for GOF a related to c is defined as g of f of x for all x implies a. Right? So in this video we discuss the algebra of function, addition, subtraction, product, quotient and composition of function. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.